So design of steel structures module 1 basically we will study about the introduction to steel and steel structures. So steel structures are mainly a load carrying member which is made of basically structural steel area, and they also transfer the load within them and to transfer the load to the ground. So as we can see, ഈ ഒരു മെമ്പർ എന്ന് പറയുന്നത് സ്റ്റീൽ മെമ്പറാണ്. ഇതെല്ലാം സ്റ്റീൽ മെമ്പേഴ്സിന്റെ ഫിഗേഴ്സ് ആണ്. ഈ സ്റ്റീൽ മെമ്പേഴ്സ് ലോഡ് ആക്ട് ചെയ്യുമ്പോൾ ആ ലോഡ് ട്രാൻസ്ഫർ ചെയ്യാൻ പറ്റണം, സേഫ് ആയിട്ട് ഗ്രൗണ്ടിലോട്ട് എത്തിക്കാൻ പറ്റണം. So usually they are mainly used in high-rise building area. So some of the examples are listed here. Roofs in factories, cinema halls, railways, ഇതൊക്കെയാണ്. So what are the advantages of and disadvantages of steel as a structural member? So advantage എന്ന് പറയുമ്പോൾ എന്തായിരിക്കും? അതിന് ഹൈ കംപ്രസീവ് സ്ട്രെങ്തും ടെൻസൈൽ സ്ട്രെങ്തും ഉണ്ടായിരിക്കും. മീൻസ് അതിന് റിസർവ് സ്ട്രെങ്ത് കൂടുതലായിരിക്കും. ഈ പർട്ടിക്കുലർ കെ ജിക്ക് അതിന്റെ ലോഡ് കേപ്പബിൾ, അതായത് കപ്പാസിറ്റി ഓഫ് ലോഡ് താങ്ങാനുള്ള റേറ്റ് കമ്പയർഡ് ടു കോൺക്രീറ്റ് വളരെ കൂടുതലായിരിക്കും. സോ നമുക്ക് കുറച്ച് വെയിറ്റിൽ തന്നെ ഒരുപാട് ലോഡ് ട്രാൻസ്ഫർ ചെയ്യുന്ന മെമ്പേഴ്സ് ക്രിയേറ്റ് ചെയ്യാൻ പറ്റും. സോ ഇറ്റ് വിൽ സേവ് സ്പേസ്, ഇറ്റ് വിൽ റെഡ്യൂസ് ദ വെയിറ്റ് ഓഫ് ദി മെമ്പേഴ്സ്, and also it has a good aesthetic view, sleek ആയിട്ടുള്ള മെമ്പേഴ്സ് കിട്ടും. And since these steels are fabricated in factory, അതിന് നല്ല ക്വാളിറ്റിയും ഡ്യൂറബിലിറ്റി ഉണ്ടായിരിക്കും. And then fasting very speed ആയിരിക്കും കൺസ്ട്രക്ഷൻ. നോർമൽ കോൺക്രീറ്റ് കാസ്റ്റ് ചെയ്ത് ക്യൂർ ചെയ്യുന്ന ടൈമിന്റെ ആ ടൈമിനുള്ളിൽ സ്റ്റീൽ നമുക്ക് ഇറക്ട് ചെയ്ത് ബോൾട്ട് ചെയ്തോ ബിൽഡ് ചെയ്തോ ചെയ്യാൻ പറ്റും. And also it is scrap valuable. So after a use, we can also dismantle it and we can next side പോയി കാസ്റ്റ് ചെയ്യുകയും ചെയ്യാൻ പറ്റും. So we can say that steel is advantages in പറയുന്നത്. So one of the disadvantages എന്ന് വെച്ചാൽ അതിന്റെ high initial cost ആണ് compared to concrete, and also the problem of corrosion. So properly maintain ചെയ്തില്ലെങ്കിൽ corrosion ഉണ്ടാവാറ്, and also the problem of low fire resistance. Extremely heat ഉണ്ടായി പെട്ടെന്ന് തന്നെ ഫയറിന്റെ ടെമ്പറേച്ചർ കൂടി ബേൺ ചെയ്യാനുള്ള റീസൺസ് ഉണ്ടാവും. So as we can know that steel is an alloy of iron and carbonate. So the mechanical property describes on how the various elements are found in steel. So this is just a figure showing the manufacturing process of a steel element. So basically the iron ore, iron ore എടുത്തിട്ട് നമ്മൾ oxidization ചെയ്ത് impurities remove ചെയ്തിട്ട് we will hot roll into different sections. So this is the rolling process. So through these rolls, different shape of section will be created. So iron is basically very thin and has very little mechanical strength. So when we add carbon with iron, it will increase the tensile strength and hardness of the steel. Thus, the steel is basically an alloy of carbon and iron. Iron will be present in the most abundant 95 to 97%. So what is the optimum percentage of carbon? Usually the optimum percentage of carbon is between 0.12 to 0.25%. So ഈ ബ്ലാസ്റ്റ് ഫർണസിനകത്ത് ജനറേറ്റ് ചെയ്ത സ്റ്റീലിനെ പിഗ് അയൺ എന്ന് പറയും. സോ ഈ പിഗ് അയണിനെയാണ് നമ്മൾ കാസ്റ്റ് അയൺ, റോട്ട് അയൺ ആൻഡ് സ്റ്റീൽ ആയിട്ട് കാസ്റ്റ് ചെയ്യുന്നത് ബേസ്ഡ് ഓൺ കാർബൺ കണ്ടന്റ്. So this table shows the different types of pig iron. That is cast iron 2.5 to 4.5% carbon, whereas in wrought iron it is only less than 0.2%. It is one of the purest form of steel. And normal steel, that is mild steel, and the steel which are commonly used, the carbon content will be from 0.1 to 1%. Since the carbon percentage is higher in cast iron, it is having high strength, it is having anti-rust property. But the problem is that it is very brittle iron. Since it is anti-rust, it is used to making water pipes, sewer pipes, and drain pipes. So നമ്മൾ usually കാണുന്ന water transport in the pipes എല്ലാം cast iron pipe. Next is wrought iron. So wrought iron carbon percentage വളരെ കുറവാണ്, less than 0.2% only. So there may be more ductile. Since the percentage of carbon is lesser, it is subjected to corrosion easily. So it is mainly used in application where the ductility is very important. That is, it is used in chain, crane hooks, and railway couplers. Next is steel, which is commonly used. The percentage of carbon is 0.1 to 1.1%. So basically here it is having some kind of strength and ductility. It is also rust easily since the amount of carbon is lesser compared to cast iron. and also it is used to make structural steel, boards, nuts, and rebar. So these are the various types of pigment. So steel is further classified into mild steel, medium carbon steel, and high carbon steel. So already we discussed that steel is an alloy of iron and carbon, where carbon is present from 0.1 to 1.1 percentage. So if the percentage of carbon is less than 4.1 percentage, we can call them as mild steel. If the percentage of carbon is between 0.25 and 0.6%, it will be medium carbon steel. And if it is greater than, that is 0.75 to 1%, it will be high carbon steel. Okay. Some of the properties of steel is given below. The steel density 7,850 kilogram per m3 value is 78.5 kilonewton per meter cube. So these properties are given in IS 800 in clause 2.2.4. So what's the modulus of elasticity of steel? It is 2 into 10 raised to 5 Newton per meter square. All of you know that really. Portion ratio usually 0.3 elastic and 0.5 plastic, and modulus of rigidity G is 0.8 into 10 raised to 5 Newton per meter square, and coefficient of thermal reflection alpha is equal to 12 into 10 raised to minus 6 per degree Celsius. So ഇതെല്ലാം നമ്മുടെ IS 800 കോഡിൽ ക്ലോസ് 2.2.4 കൊടുത്തിട്ടുണ്ട്. So next അടുത്തതായിട്ട് we will study about the types of structural steel sections. So steel is basically it is rolled into redwood shape during fabrication, which we already discussed. What are the common sections of steel available in the market? So first one is the I section. So this is a typical wide angle I section, normal I beam. Then there is a T section, shape is like a T. Then there is a channel section, C-shaped section. This is called as channel section. Then there is an angle section or an L-angle section. Then there is this square tubes, circular tubes, like that. So different shapes, that is different types of section, and these properties are given in the standard steel tables. Now, what is rolled I section? So I section basically means it is having a web area and there is a flange area. So suppose if it is the types of I section usually used in India, first one is ISJB, which means Indian Standard Junior Beam. Next is ISLB, Indian Standard Light Beam. Then ISMB, Indian Standard Medium Beam. Then there is ISWB, which is Indian Standard Wide Flange Beams, and ISHB, which is Indian Standard Heavy Beams. So each beams will be having its own applications. Usually I-beams or the I-sections are used as beams and columns. Normal structural buildings, structural steel-based buildings or the structures, I-sections are used as beams and columns. So here it is a figure showing an I-section as a column and I-section as a beam. So there are these types of ISJB, LB, MB, WB, HB. ഓരോ ടൈപ്പിലും ചില കേസിൽ അത് ബീംസ് ആയിട്ട് യൂസ് ചെയ്യും ആൻഡ് ചില കേസിൽ അത് കോളംസ് ആയിട്ട് യൂസ് ചെയ്യും. So usually LB means light beams ആയിരിക്കും. So it will be used as roof beams where loads are lesser. MB means medium beams, which is commonly used as floor beams. കുറച്ചുകൂടി heavier load ആണ് എടുക്കാൻ സാധിക്കും. WB എന്ന് പറയുന്നത് wide flange beams ആയിരുന്നു. Obviously it is having higher moment of inertia, so it is will be used as columns, which machines used to transfer compressive load. So example, if it is given as ISMB 500 and 0.85 kN, this IS denotes Indian Standard I sections, NB denotes medium beams, 500 denotes the depth of the beam, and 0.85 denotes the length per unit level. So 500 means this is the depth, that is the distance from the top flange and the bottom flange. Okay. This is the width of the beam flange, that is BF. T is the thickness of the flange, is TF, and TW is the thickness of the web. So എല്ലാവർക്കും അറിയാലോ I beams usually ഈ കാണുന്ന പോർഷൻ ഫ്ലാങ്സ് എന്ന് പറയും നടുക്കുള്ള പോർഷൻ വെബ് എന്ന് പറയും. So next type of section is the T section. So T sections are like these four types are to be divided: ISNT, HT, LT, and ISLT. So ISLT means Indian Standard Normal Beam, HT means Indian Standard Heavy Beam, and ISLT means it is a special name for The T sections are normally used to transmit bracket loads to columns. So കോളത്തിൽ എക്സെൻട്രിക് ആയിട്ട് ഏതെങ്കിലും ലോഡ് ആക്ട് ചെയ്യണമെങ്കിൽ ബ്രാക്കറ്റ്സ് ആയിട്ടുള്ള സെക്ഷൻസ് കൊടുക്കാൻ വേണ്ടി നമുക്ക് T sections use it. So T section also the top portion will be classed as a flange and the middle portion will be called as a web. So H will be the depth of the T section and B will be the width. And this curved portion is called as a fillet. Next is the channel sections. The channel sections are classified as ISLC light channel, MC for medium channel, and there is ISSC for Indian standard special sections. The channel sections are usually used as beams, especially in case of roof trusses, because they resist the bending moment. So there are examples they are used in parliaments, and also sometimes to make meter columns we use larger angles like channel sections like IS, HC and LCM. So I'm missing the size C. So they are used in making meter columns also. So sometimes double channel sections are used in both trusses. So channels also has a flange. So പൊട്ടുകൊണ്ടിരിക്കുന്നതിനെ flanges എന്ന് പറയും. Middle portion വെട്ടെന്ന് പറയും. So bottom will be having it and the flange portion is there. So that is happening. So different types of sections has different types of applications. So next type is the angle sections. That is Indian standard equal angles ISA and Indian standard unequal angles, and there is Indian standards bulb angles also. So this is a figure showing Indian standard angles. So angles will be having two portions. So this is one leg and this other leg. If both the length are equal, we can say it is having equal angles. So sometimes one leg will be larger than the other. So it is called as unequal angles, and this is a bulb angles. Mainly they are used as axial angles in parliaments, that is in truss. So they are used to make built-up sections, connection members between beams and columns, as masons and battens, etc. And bulb angles are mainly used in shipbuildings. So next we study about connections. So that is our both welded connections and bottle connections are very important. One important problems will be coming. So basically, during what is the need of connections? So while fabricating structures, we are basically joining different elements of a structure. That is, beam, columns will be joined together. So facilitate this joining, we use connections. That is, fabrication of structure between two or members are made through connections only. So here we can see that this is one beam I section. It is connected with I section using a plate, and this is the bolted connections. So this is another joint, and this is joined by welded connections. So basically, connections help to make up a buildings. So connections are also using built-up sections also. So we will be studying that in our later lectures. So built-up sections and also in the very long sections, because in factories the standard sections will be like 6 meter, 12 meter line factories level. So we are basically require connections to join them to make it very lengthy or very large sections. So these are also the critical members in the structure, because if a connection fails in a structure, basically the whole structure is liable to collapse. So we must be very careful when designing that connection must not fail before failure of a member. So member can fail either by shear or flexure or by bending, etc. So always in steel structure, we must design in such a way that we must always design a connection not to fail. Even we design like that only, but always make that the connections must not fail before members. So this, because another reason is that the connections are less ductile compared to members. Usually in steel structures, we are using steel sections. So here in this figure, we can see these are steel sections. And one of the properties of steel section, it is having ductile properties. Since we are adding iron and carbon to make steel, carbon incorporation will provide ductility properties to the steel. So what happens compared to connections? They are short members using bolts and nuts, or sometimes using welded. So they are compared to these members, they will be brittle in nature. So we must see that connections always within the fact that connections are always less ductile than members. So based on the method of fabrication or what type of method we use to join these members, usually the connections are classified as riveted joints, mortared joints, welded joints, or we can use a combination as well. Next we study about the joints, that is based on the alignment of the plates. Joints are classified as lap joint and butt joint. So this is the important point here. So lap joint means here it's the simplest form of joints where plates are connected overlapping one another. So if we want to join one large plate with another plate, we can simply lap them with particular distance and we can bond them to create very simple large piece. So this is a single line lap joint. What about butt joint? Butt joint where we are joining these two plates, that is shading like one plate and ഒരേ പ്ലെയിനിലാണ് ജോയിൻ ചെയ്യുന്നത്. So we have to provide a cover plate. So ഒരു സൈഡിൽ കവർ പ്ലേറ്റ് കൊടുക്കുന്നതിന് സിംഗിൾ കവർ എന്ന് പറയും, രണ്ട് സൈഡിൽ നോക്കും ഡബിൾ കവർ. So these types of joining, these plates are joined in the same plate. So plates are connected in the same plate using cover plates, then we can say it as a butt joint. So this is the basic difference between a lap joint and a butt joint. Next we study about bolted connections. So we know that bolt is basically a metal beam with having a head on one end and a shank and a threaded area on the other end. You see the nut. The threaded area on the nut which is tight and button. So usually the distance between these two portions is called as the grip length. Sometimes indirectly there will be plates. So the distance from the head and the washer is basically called as the grip length. And this smoothed face is called as shank area and the threaded portion is called as the thread area. So it is the region of threading in shank. So grip length is where there is no threading in shank. We normally call as grip length, and nominal length will be the total thread length plus the grip length will be the total length. So, it will be the total. So this is a figure of a bolt showing the head, shank, thread, and the grip length. So this is the advantages of using bolted connections. I just to pause the video a little. What are the advantages using bolted connection? So what is this? So less manpower is required here. That is, a single or few laborers can install several boards inside the steel sections. These boards are of different grade sizing. High strength friction boards are much stronger than rivets, and thus we can reduce the number of riveted boards, because as we increase the grade of board, we can use lesser number of boards. So a lesser number of boards in the plate also, because basically we are in water connection, where basically we are creating a board basis board. So each time we create a board, the strength of the section of the plate is being compromised. Next advantage of water type connection is that they require less fastness than riveted joints. Okay, because we can use high strength water and the reason. And bolting operation is silent and relative than riveting process. Riveting process is very high sound, we are applying pressure for riveting purposes. So compared to that, bolting is much more silent. And also riveting, we are using high temperature for riveting purposes, but in bolting, basically it is a cold process. So there is no chance of any riveting or welding or risk of fire, etc. And also compared to rivet, the advantage of bolt is that rivet can be easily removed. Now we discuss the disadvantage of bolted connection. So bolted connections have lesser strength in the axial tension area, as the area of the root of threads are lesser, because only a small area of the bolt will be joined with the plates. So there will be a chance of always failures in shear and wearing. And also the problem is that when dynamic load comes, that is when variable loads, if the load is increasing or decreasing, then varying in the load value, bolt will easily get loosened. So once the tightness is lost, it will reduce the strength of the load carrying capacity. And usually unfinished bolts are lesser strength due to non-uniform diameter. So compared to rivet, which is very uniform, these bolts will be having a shank and thread area, which causes some variation in strength also. And aesthetic looks connection will be affected, which is compared with the welded connection, which having a smooth, seamless joints. Both will be having bolts protruded along the joints, which is sometimes aesthetically displeasing area. Now we discuss the types of bolts. So what are the different types of bolts? So types of bolts, basically it is having an ordinary bolt and high strength bolt. We can based on the strength, or we can say it's black bolt or turn bolt and or high strength friction bolts based on the type of shank we are using. So briefly we will study about what is basically black, and it's very not very important for the exam point of view. So mainly for the exam point of view, mainly we can study what are the advantages of water connections or limited connections, or what are the advantages of welded connection or water connection. This is a basic question that can ask. But generally, what is the advantage of steel or steel structures? Okay, we generally can chance only. Or we can study what are different types of boards. So basically, what is blackboard means basically whatever ordinary board we are using, like blackboard. It is called as its grade will be from M5 to M36 and the diameter size M34 means the diameter will be 36 mm. And usually for structural steel work, we use M60, M20, M25, M30. So this range of boards will be forming a lot of structural steel works. That is for directional multi-story structural buildings. And if you are having some kind of dynamic loads, that is very clearly important thing for a castrated nuts. So nuts will be having a use on them. So it can be it is snap type of joint. So mainly, basically, we use these woven doors for light structures having static loads. What we use mainly use for bundle members in roof trusses. So where if there is any chance of vibration or impact of a taper, we cannot use these ordinary doors. Okay, ordinary doors, അങ്ങനത്തെ കേസിൽ use ചെയ്യാൻ പറ്റത്തില്ല. So definitely they are favored from some mild steel ഉണ്ടാകുന്നത്. Usually, if you are using only or blackboards, this type of joint will have bearing type of joints. So they are locally transferred by the interlocking and bearing electronically, and forming grade is 4.6. So what is 4.6? We will discuss in the coming classes. So next type of board, when compared to our ordinary board, is called high strength friction board side. Diameter will be from M60 to 30, and these are made from medium carbon heat treated for an alloy steel. Ordinary board which is made from mild steel iron. So obviously the strength will be lower in ordinary board and higher high strength friction board. So here load is transferred by the name itself, that is by friction, and it is load shear. So that is in friction basically when we tighten a clamping pressure will generate and load will transfer through that friction between the board and the plate. And this weight will be higher, say 8.8 and 10.9 multiplied. So this is basically showing the advantage of this high strength friction board. So next we study in detail about the lap joint and butt joints in water connection. So this is more important for the exam. So exam point of view, കൂടുതൽ ചോദിക്കാൻ chance ഉള്ള ഏരിയയാണ് design of lap joint and butt joint. So what is basically known as this lap joint? So lap joint means there will be the paste over one over the other. Plates will be overlapping each other. So in lap joint or paid and one. So here there will be two different planes. That is, if this is the force P1 and if this is P2, then P1 and P2 will be lying in different planes. So there will be some gap between these two forces. So due to which there will be a eccentricity, and this eccentricity will create a couple. So in lap joint, again, an extra moment has to be resisted. This joint must resist this extra moment or couple due to eccentricity between the plates. That is basically due to geometry of lap joint. And as per IS 800, if the grip length is greater or less than 5 times this diameter, we can neglect this effect of bending. So what is the grip length? So in this figure, grip length basically means it is a distance between the head of the board and the nut portion. So basically what happens here is that usually we can take the total distance or the total thickness of plates as the grip length. So here this is the plate 1 thickness and this is plate 2 thickness. The sum will be called as grip length. So our grip length value is less than 5 times the diameter of board using, then we can neglect the effect of this extra moment. So another feature of this lap joint is that it is the least efficient joint. And when the butt joints, single cover and double cover, this is the least. Why it is called as least efficient joint? Because this lap joint will create an extra moment. So we have to design that also. We're going for larger or thicker plates. So here the boards are subjected to shingle, shear and bending. So here due to lap joint, when we apply the force, there will be shear force or the shear stress developed due to the bearing. So here what happens? The plate, the boards. So here basically we are creating force in the plate and then we are placing the boards. So the surface of the plate will apply a shear force over the bolt area, that is shank area of the bolt. So if it is having two plates, this is called a single shear type of mortar joint. And there is also an eccentricity. This is the eccentricity. So what happens? There will be also will be bending. So basically due to bending, the bolts will be bending in like this. It will be rotating and it will be bending like this. So here bolt will be subjected to single shear and also bending. In butt joint, what happens is that the plates are joined together in a single plate. So both these plates will be joined together in a single plate. So okay, so both this plate will be same. So the whole line of application of the force will be lying in a single plane only. So in lap joint, what happened? The line of actions of the forces were at different level at an eccentricity. So there are two types of butt joints. If you are providing one cover plate in one side, is called a single cover, and if you are providing two cover plates on the bottom and top. So either way, we require a cover plate for joining this plate in a single plate. So third that we cannot join using bolts. So in single cover butt joint, the line of action is same, but the connection is not symmetrical. Symmetrical means there is some weightage of cover plate on top side. So it is not even though the line of action is same, the connection is not symmetrical. So what? But in double cover joint, the line of action is also same, and also the connection is symmetrical because there is an upper cover plate and lower cover plate. So thus we can say that double cover butt joint as the most efficient joint. Okay, and the shear capacity of bolts will be double in case of double cover butt joint, because why? Because there will be two plates to resist the shear, and force will basically become half when there are two shear plates. So basically the bolt will be doubled in case of. So for example, if you're trying to find the shear capacity of both, the value of shear in case of a lap joint and a single cover butt joint, it will be lesser compared to double cover. There will be twice as much of shear capacity will be there for the bolt. So the shear capacity of double shear will be twice the shear capacity of bolt in lap joint or a single cover butt joint. The next important and relevant topic is failure of connections, failure of important joints. So basically, in 3 months, university की चोरी के chance of idea. What are the failures in the motor joint? The failures in motor joint. So usually, the failure of a connection means either the bolt will fail or the plate at the location of connection will fail. So we have to see both these two aspects, that is whether what are the failures that may occur in both and what are the failures that can occur in plate. So these are the failures that may occur, that is the shear failure, bearing failure and tensile failure in those, and also similar in place there will be shear failure, bearing failure and tensile failure. So what is the shear failure? So when load is applied on plates, the shear stresses are developed when plate slips due to these loads. So that is this is a normal case and then this is the plates. So the shaded portion of the plates. So when the load exceeds, what happens? The edge of the blade will exert a shear force on the bolt. So when in lap joint and single cover butt joint, the shear acting plane will be one only. So in double cover butt joint, there will be two plates. That is, there will be one cover plate here, there will be one cover plate at the bottom, and there will be two plates. So the number of shear plane will be this and this. So we can say the bolt will fail in double shear in case of double cover butt joint, and in case of single cover butt joint, we can say bolt will fail in single shear. So this is a shear plane. So the maximum factor shear force in the bolt may exceed the normal shear capacity of the bolt. So due to this load, the load is absolute P, or suppose any load, there will be developed a shear force at the contact of this plate and bolt. So when the bolt itself has a shear capacity, so when this force exceeds the shear capacity, the bolt will basically fail. So this also shows the shear force developed. So shear force is developed in this way, and due to which the shear failure of bolt will occur. Next is the bearing failure of bolts. So what do you mean by bearing failure or bearing stress? So it is a stress which is developed or exerted at the point of contact between two different materials. That is, when one material pushes another material, with the difference in material, there will be bearing stress will be developed. So there is bearing stress on plate and there is bearing stress on bolt. So this both can occur. So in this case, what happens is that the bolt is having high strength compared to the plate. So what happens? The bolt will exert a bearing stress over the plate, and there will be one extension of this volume. Okay. So in this case, if the bolt is having a lesser strength material, suppose a normal or black bolt is, if the plate is having a higher strength, what happens? The plate will exert the force of bolt and bolt will crush like this due to bearing failure. So this is a figure showing the bearing failure for bolt and this is the bearing failure for plate. So plate will be subjected to failure in case if we are using a weaker plate and a stronger bolt. Vice versa in the case of this. So the bolt is crushed around half circumference. The plate may be strong in bearing, and the heavier stress plate may press the bolt shaft. We know that the non-threaded portion of the bolt is called as shaft. So the plates are made of high strength steel and the bolts are made of non strength steel. So this is scenario of occurring a bearing failure bolt. So bearing failure bolt ഉണ്ടാവണമെങ്കിൽ ബോൾട്ടിൽ ഫെയിൽ ഉണ്ടാവണമെങ്കിൽ പ്ലേറ്റിന് ഹൈ സ്ട്രെങ്ത് മെറ്റീരിയൽ ആയിരിക്കണം ബോൾട്ട് ലോ ഗ്രേഡ് മെറ്റീരിയൽ ആകുമ്പോൾ ഒബ്വിയസ്ലി അവിടെ ഫോഴ്സ് എക്സർട്ട് ചെയ്യുമ്പോൾ ഷിയർ ഫോഴ്സ് ഉണ്ടാവും ഷിയർ ഫോഴ്സ് കാരണം ബിയറിംഗ് ആയിട്ടുള്ള ഒരു ഭേദം ഉണ്ടാവും സ്ട്രെസ് ബിറ്റ്വീൻ ദ പ്ലേറ്റ് ആൻഡ് ദ ബോൾട്ട് ആൻഡ് ദിസ് ടൈപ്പ് ഓഫ് ഫെയിലിയർ മേ occur. Next type of failure. So what we have discussed is we have discussed the shear failure of bolt, bearing failure. No, there is a tension failure of bolt. So due to this tightening, if we increase the tightening at a particular limit, there are special tightening with the gauge measurement instrument for bolt. But if we exert a particular pressure, the what will happen? There will be a tensile force to be created. So due to tightening, the tensile force will be double like this, total bolt, and it is the bolt will feel like this. So just like we do a tension test on a mine steel bar. Here this is a making bolt. So the bolt is subject to tensile force fail if the applied factors tensile force is greater than the tensile strength of the bolt. The tension capacity depends on tensile strength and the minimum cross section area of the front. Okay. Next we study about the types of failures in place. So first type of failure is called as the shear failure or the block shear failure of the place. So here we discuss in earlier case for a bearing failure to occur in a bolt, what is the situation is that plate of higher strength and bolt of lesser strength. So in this case, for a shear failure to occur in plate, the bolt must be higher strength and the plate must be lesser strength compared to bolts. So here the bolt here will be higher strength. When load occurs, what happens? The contact between the bolt and plate, the bearing type of a failure occurs. Not shearing, because if it is the force is parallel through the shear stress, and due to the lesser value of this edge distance, what happens is that there will be a block type of a shear failure. Block means like a rectangular block. So bolt may have place at lesser end distance. So this can be prevented by adopting sufficient end distance or edge distance. So usually in design we don't consider these types of shear failure. Right? So we ensure it by providing what adequate edge or end distance. So may occur when block of material within bottom area breaks away from the remaining area because of the lesser edge distance. Occur when fewer bolts of high strength are used. Usually it may occur when use high strength bolt but fewer numbers. Also check by observing the specification of edge distance also. So this is the shear failure of plates. Next is bearing failure of plates. So as we discussed, we are using high strength bolts. What happens during slip? Bolts are subjected to shear force. They come in contact with the plate will crush. The plate material is weaker than the bolt material. Here also the bolt spacing and distance will influence. That is the spacing between the bolts. If you see the pitch or bearing distance, if it is adequate, we can prevent this type of bearing failure. So both the type of failures like block shear and bearing failure can avoid if you provide proper spacing between the bolt and edge distance. The last is the tensile failure or tearing of plate. This is basically dependent on the load mechanism and the strength of plate. So this is an example for tensile failure. Plate is tensile load. This is the weak point that there will be crack along the bolt line and the plate fails. The tension value occurs because the bonds are stronger than the plates. Definitely, because corresponding to bonds, the plates will be weaker. So what happens? The plates will be subjected to the tensile failure. The tension both the gross area and net area may be present. So in case of tension, we can consider the gross area. So what is the difference between gross area and net effective area? Usually this is a plate. So what happens for bolting? We will cut holes in the plate. Okay. So this is the side view of a plate. This is the area of it. So due to this bolting, what happens is that we will cut area like this. Okay. So area will be cut like this. So this is called as the net effective area. So net effective area will be the plate area minus bolt area. So that so tension can occur. Sometimes it can occur here. Sometimes it can occur exactly along the net effective area. This is called as net effective area because already there will be hole for placing the bolts. So it will create weak areas inside these plates. So only when the tensile force act, the crack will be open or the failure will be occurring along this net effective area plane. So next topic is the grade of bolts. So basically grade of bolt എന്ന് വെച്ചാല് basically if we are like writing a grade of bolt as 4.6 grade. So what is its significance? So it signifies that the ultimate load Fu it is 400 MPa or megapascal or Newton per mm square. If the grade of bolt is 8.8, the 8 is the x into 100 denotes the ultimate load. So basically grade of bolts is the yield and tensile strength of the bolts. Usually we will write in the form of x stored by the x will denote the what the x will denote the ultimate and y will denote the yield. So for example, if the bolt value is 4.6 grade bolt is given, so അങ്ങനെയാണെങ്കിൽ ആ 4 into 100 ആയിരിക്കും, that is 400 MPa ആയിരിക്കും അതിന്റെ FU അല്ലെങ്കിൽ അതിന്റെ ultimate load എന്ന് പറയുന്നത്. ഡിസൈൻ കാൽക്കുലേഷൻ യൂസ് ചെയ്യണം. What about its yield strength എന്തായിരിക്കും? The yield strength will be point y into FU. So what is point y? This is 0.6. 0.6 into 400, which will be 240 megapascal will be the FYB. So this is FUB and FYB. So what is FUB? So U and B are suffix, that is FUB, where U denote ultimate, B denotes bolt. So U denotes ultimate and B denotes bolt. Similarly, what is FYB? Y denotes yield and B denotes bolt. So another example is if grade of bolt is 8.8, so ultimate strength FUB will be, this is x point y, so it will be 8 into 100, which is equal to 800 megapascal, and what is FUY will be that 800 into 0.8, so 800.8 will be 640 megapascal. Next important topic in the design of bolted joint is the terms pitch and gauge distance. So what is the difference between pitch and gauge distance? നിങ്ങൾ പ്രോബ്ലം ചെയ്യുമ്പോൾ pitch gauge distance ഇടയ്ക്ക് മാറി തിരിഞ്ഞു വരും. So this is the figure showing a double cover butt joint. This is the plate and this is the cover above and below. So and this is the plan view, so seen from the above. So usually we are, this is the two plates, this one, this were the two plates, and this is the cover plate. So using these 4 plus 4, 8 bolts, we are creating the bolted connection. So what happens here is that this is the direction of load. The distance between the bolt in the direction of the load is called as pitch. So ഈ ലോഡിന്റെ ഡയറക്ഷനിൽ എടുക്കുന്ന സ്പേസിങ്ങിനെ പറയുന്ന പേരാണ് pitch. Okay, so pitch is the distance between two consecutive bones measured parallel to the direction of force. So what about gauge distance? ഇതിന്റെ നേരെ opposite ആയിരിക്കും, that is it is the distance between two consecutive measured perpendicular direction. So this is the perpendicular direction there. Here the force is in this direction and this is the perpendicular direction. അപ്പം ഇതായിരിക്കും അതിന്റെ pitch distance, sorry, gauge distance. So gauge distance will be this value. This is the distance measured perpendicular direction of force. So which will be the distance measured parallel to the direction of force, and gauge distance will be distance measured perpendicular direction of force. So usually in IS 800 there is 2007. Actually this pitch distance and gauge distance will be given for a minimum pitch distance എത്ര വേണം maximum എത്ര വേണം എന്ന് പറയുന്നുണ്ട്. So I will mention the clause later. So usually pitch distance എന്ന് പറയുന്നത് minimum 2.5 dB കൊടുക്കണം. So here tension members, the pitch distance will be maximum will be in the range of either 16T or 200. So we can only provide either 16 times the thickness of plate or 200. Whatever is maximum. For compression, it will be 12 times the thickness of plate for 200. So for raw mirrors, this is given 101 plus 4 to 200, and for staggered pitch, this pitch distance must not be less than 75 mm. The maximum value. So the minimum will be this only. Similarly, for gauge distance, same conditions will follow. But for tension members, the maximum gauge distance adopted must be within the 32T, that is 32 times thickness of plate or 300 mm. So actually the code will parameter, so just we can get from the code. Okay. So next important term after pitch and gauge is the end distance. So what do you mean by difference between end distance and edge distance? Similar to pitch and gauge, end distance is distance between the center of board and the edge measured parallel to the direction of force. So ഇതൊരു ഫോഴ്സിന്റെ ഡയറക്ഷൻ ആണെങ്കിൽ അതിന് പാരലൽ ആയിട്ട് മെഷർ ചെയ്യുന്നതായിരിക്കും. സോ അത് എന്ന് പറയുന്നത് അതിന് പറയുന്നത് എൻഡ് ഡിസ്റ്റൻസ് എന്ന് പറയും. സോ സെന്റർ ഓഫ് ബോൾട്ടിൽ നിന്ന് എഡ്ജ് ഓഫ് ദി പ്ലേറ്റ് ആയിരിക്കും. സോ എൻഡ്. വാട്ട് ഇൻ എഡ്ജ് ഡിസ്റ്റൻസ് സെയിം കണ്ടീഷൻ വിച്ച് ഇസ് മെഷർഡ് പെർപെൻഡിക്കുലർ ടു ഡയറക്ഷൻ ഓഫ് ഫോഴ്സ് ആയിരിക്കും. സോ ഹിയർ ഇൻ ദിസ് ഫിഗർ ദിസ് ഈസ് ദ പിച്ച്. So each pitch is measured parallel to the direction of force. So this will be the which distance? End distance. Okay. The first case I end distance എന്ന് പറയുന്നത് എന്തായിരിക്കും? It is the distance from this center of this board towards this. ഈ distance എന്തായിരിക്കും? ഇതായിരിക്കും end distance. So it is actually given here the end distance. What about edge distance? Is the distance from the center of board towards the edge of the plate measured perpendicular direction. So these are the four terms. That is, this is the pitch, gauge, edge distance and end distance. So എപ്പോഴും ഓർത്തിരിക്കുന്നത് വെച്ചാൽ pitch എന്ന് പറയുന്നത് parallel, P for P. So pitch will be parallel, and what will be gauge? Obviously pitch parallel, gauge perpendicular ആവും. Similarly end distance means what? It is parallel, so opposite will be edge distance, which will be perpendicular. So actually in code there is a maximum value of edge distance. So minimum value normal diameter അനുസരിച്ചാണ് കൊടുക്കുന്നത്, minimum edge distance of bolts. So usually we can adopt this like these equations are all given in the code itself. So maximum edge distance will be 12 times T, thickness of the plate, into E. Here E is equal to root of 250 by Fy. So normally problem ചെയ്യുമ്പോൾ Fy എന്ന് പറയുന്നത് 250 തന്നെ ആയിരിക്കും. So obviously ഈ ടൈം ആയിട്ട് മാറിയിട്ട് maximum edge distance കൊടുക്കാൻ പറ്റുന്നത് 30 ആണ്. അത് നമുക്ക് ഡിസൈൻ്റെ സേഫർ സൈഡിൽ we cannot simply increase the edge distance, but there is a limit provided in the our IS code, which is 12T into E, where T is the thickness of thinner plate. So എല്ലാവരും നോട്ട് ചെയ്യണം, T എന്ന് പറയുന്നത് thickness of thinner plate ആണ്. There is another topic regarding the size of bolt hole. Some calculation we use the diameter of bolt hole instead of the diameter of holes. So usually if the nominal size is like 12 to 14, I usually apply like a allowance, that is nominal diameter of the fastener plus clearance an extra 2 mm. So usually the standard clearance with the width of the slot, this is given. Usually in questions in exams the nominal size is usually between 16 and 22. So അതുകൊണ്ട് നമുക്ക് സ്റ്റാൻഡേർഡ് ക്ലിയറൻസ് +2 ആഡ് ചെയ്തിട്ട് അതായിരിക്കും ബോൾട്ട് ഹോളിന്റെ മീൻസ് ഡയ എന്ന് പറഞ്ഞ് എഴുതാൻ പറ്റും. സോ യൂഷ്വലി നമ്മൾ അപ്ലൈ ചെയ്ത സ്റ്റാൻഡേർഡ് ആയിരിക്കും. സ്റ്റാൻഡേർഡ് ആകുമ്പോൾ 16 + 2 ആണ് അപ്ലൈ ചെയ്യേണ്ടത്.